All right, folks, get ready for a deep dive. Today, we are exploring this paper, Progressive Growing of Video Tokenizers for Highly Compressed Latent Spaces.
Wow, yeah, that is a mouthful.
I know, right? But honestly, it's a paper with potential to really shake up how AI makes videos. We will drop a link down in the description in case you want to follow along.
I think one of the most exciting parts of this paper is the potential for longer and just better videos made by AI. Like, think about how cool it would be to have AI make immersive entertainment or make educational content that is actually engaging, or even like hyper-realistic simulations.
Okay, yeah, I'm with you there. Those are some really awesome possibilities.
Yeah.
But I'm guessing it's not all smooth sailing, right? What are the big challenges they're trying to tackle?
Well, the main problem is how AI models deal with video data.
Uh-huh.
So to process video efficiently, they need to compress it, right? It's basically translating video into a simpler code. Current AI is pretty good at squishing down the individual frames, but it's not so great at compressing in time without losing important detail.
Oh, okay. So it's like trying to fit a whole movie into a tiny file. You lose a lot of the good stuff.
Exactly. And that really limits the kind of videos AI can make, both in terms of how long they can be and how good they look.
Right, so it's not just about making the file smaller, it's about keeping all the stuff that makes a video a video. Does that make sense?
Yeah, totally. Think of it like this. You try to turn a movie into one of those little flip books, but you only have a few pages to work with. You're going to miss a lot of the action, and it's going to look really choppy.
Yeah. Okay, so that brings us to ProMag, the star of today's show. This paper proposes a whole new way to compress video, and it doesn't try to do it all at once,
I
right?
got it. ProMag uses something called progressive growing. It starts with AI models that are already good at handling lower levels of compression and builds on them step by step, adding layers that focus on the missing information needed to put the video back together.
So, like, you wouldn't build a house by just throwing all the materials in a pile at once, would you?
Right, you start with a strong foundation and carefully add on, making sure each part fits together seamlessly.
Makes sense. Okay, but let's take a step back for a minute and explain how these AI models are even handling video in the first place.
Yeah.
They're using what are called latent video diffusion models, or LVDMs, right?
You got it. LVDMs, they're like the backbone of AI video generation. They learn to make videos from scratch, but they need instructions, right? They need a sort of blueprint.
Ah,
And that blueprint is what the tokenizer creates by compressing the video data. So it's kind of like the tokenizer is a translator converting that super complex visual language of the video into something that the LVDM can actually understand.
so basically, the tokenizer is making a blueprint, and the LVDM is the builder. And the better the blueprint, the better the video.
Right. And we already know that current tokenizers are kind of struggling with the time compression part of that blueprint.
Exactly. They're good at squashing each frame, but not so good at reducing the number of frames without losing crucial information about motion and changes over time.
And it's not easy to just make existing models handle higher compression.
Because then you end up with those blurry messes you were talking about.
Exactly. Instead of smooth, realistic video.
Okay. So this progressive growing thing that ProMag does seems like a really smart way around that. It's like building a much more detailed blueprint in stages. You start with a solid base and then add layers of detail on top of that.
Exactly. And get this. The researchers behind ProMag actually broke down their approach into 3 stages.
Okay. Tell me more about those stages. What's going on in ProMag, like version 1.0?
Well, in the first stage, they train a base model for 4x temporal compression.
4x compression.
Yeah.
Yeah.
It's like what current tokenizers are already doing, but it's about creating a high-quality foundation.
Mm-hmm.
Like laying the groundwork for a really well-designed house, you know?
Okay, got it. So they're starting with something proven and then making it even better. What happens next?
In stage 2, they aim for 8x compression.
Why?
They take that 4x model and they add new blocks of neural network layers, specifically to capture the information that's still missing for accurate reconstruction.
So it's like they're building a new floor onto the house, but instead of just copying the first floor, they are designing rooms that have a specific function, making the house more than just bedrooms.
That's a great way to put it. And they use this cool technique called adaptive normalization, or EDINORM, to make sure these new layers work well with the base model. Like having an architect meticulously plan how to integrate the new floor's plumbing and electrical systems with what's already there.
Okay, so it's all about carefully making sure each new part contributes something meaningful without messing up the overall design. And then stage 3, they just push this concept even further.
You got it. They repeat the process, and they go from 8x to a whopping 16x compression ratio.
Whoa, 16x. That's a huge jump. But hold on, does the video even look good at that level of compression? I've seen what happens when you compress things too much, and it's not pretty.
And that's the remarkable thing about ProMag. It achieves high compression while keeping the details. They compared ProMag with other state-of-the-art methods, and the results are impressive.
Okay, I'm officially intrigued. Spill the tea. How much better is it?
ProMag just blows the competition out of the water across the board. The reconstructed videos, they keep a remarkable amount of fidelity, even in those super fast-paced scenes with tons of detail. You honestly wouldn't even know they were compressed unless somebody told you. It's like comparing a high-def movie screen with some blurry, messed-up video.
Okay, I'm sold. ProMag is clearly a rock star when it comes to compressing video. But where does all of this lead? What's the big picture impact? Are we just talking about smaller video files here?
That's just the beginning, really. This level of efficient compression, it's like opening a door to a whole new world of AI-generated video.
Oh,
Remember, LVDMs, they create new videos from scratch, and ProMag gives them this super compact and efficient blueprint.
so it's not just about reconstructing existing videos, but enabling AI to make entirely new ones, potentially better and faster than ever before.
Exactly. And think about the possibilities. This has implications for everything, from entertainment and advertising to even stuff like education and scientific visualization.
Okay, my mind is officially blown. Let's take a deeper dive into those applications. What are some areas that you are personally excited about?
Well, one that immediately pops into mind is text-to-video generation.
Ah, yes. The dream of typing something and having AI create a whole video out of it.
Right. The dream has always been hampered by the limitations we've been talking about, but ProMag's efficient compression could change all of that.
So are we talking longer, more detailed, and just more visually stunning videos, all thanks to this new approach to time compression?
You got it. It really does feel like a paradigm shift in the making.
I'm getting goosebumps just thinking about it. But before we get too carried away with all this futuristic talk, I think it's important to understand how we got here. What were the building blocks that led to this breakthrough? What kind of research did ProMag build upon?
That's a great point. ProMag didn't come out of thin air. It builds upon a lot of research in video tokenization and these latent diffusion models.
Yeah.
We need to rewind a bit and look at how this field has evolved.
Okay, let's rewind the tape then. Where does this story begin?
Well, early LVDMs relied heavily on image-based VAEs, variational autoencoders.
Right.
These models basically treated each frame of a video like a separate image, which led to problems with things looking smooth over time.
Ah, so they were missing that crucial element of how things change over time in a video.
Right. Imagine you're trying to make a flipbook animation, but each drawing is a little different from the one before it.
Yeah, it wouldn't flow smoothly, would it? It'd look all jerky and weird.
Exactly. And that realization led to video-level VAEs, models like MagVT V2, which could actually encode entire videos and take that time element into account. That was a huge step. But these models, they still struggled to achieve really high levels of temporal compression without sacrificing quality, like we've been talking about.
So is ProMag taking the best parts of these earlier models and kind of turbocharging them with this new progressive growing approach?
Exactly. And it also takes some inspiration from other areas of AI research, like how GANs, generative adversarial networks, generate images in stages.
Ah.
They start with a low resolution and then add details. This has been successful for making images, and ProMag cleverly adapted that for time compression.
It's like starting with a rough sketch and then refining it into a masterpiece, right?
Yes, exactly. And by bringing all these different research ideas together, ProMag has cracked a major problem in AI video generation. This opens up so many possibilities.
This deep dive has been so insightful. We've gone from talking about squeezing video files to talking about AI creating mind-blowing visual content. And I feel like we're just scratching the surface here. What other cool stuff did you find in this paper?
There are some finer points that might not be obvious at first glance, but show how carefully they designed ProMag, ready to go deeper.
Absolutely. Lay it on me. What other insights did you glean from this paper?
One thing that really stood out to me was how they kept the number of latent channels constant during the whole progressive growing process.
Hold on. Before we go any further, let's make sure everyone's on the same page. What exactly are latent channels and why does this even matter?
Think of them them as the building blocks of that compressed representation of the video.
Got it.
Each channel encodes some specific visual information. So the more channels you have, the more information you can store. It's like having a bigger vocabulary to describe what you see.
Okay, that makes sense. So you would think that having more channels would be better, right?
Right.
Why would they limit themselves?
Well, that's a great question. And it really highlights this balancing act between how much information you can squeeze in and how easily the AI can learn from it. While having more channels seems like a good idea, it can actually make it harder for the AI to understand and create a good video. It's like giving a painter a million different colors. It can just get overwhelming.
Right. So it's not just about cramming in as much information as possible. It's about organizing that information so the AI can actually use it.
Exactly. And the researchers found that keeping those channel dimensions constant actually helped with that.
Interesting.
It made the compressed representation of the video compact and easy for the diffusion model to learn from. Imagine a super organized library where the AI can easily find exactly what it needs to build a video.
That's a really cool way to think about it. So sometimes less is more, huh?
You got it. And that attention to detail is everywhere in this paper. Another example that caught my eye was their solution to spot artifacts.
Spot artifacts. Okay, now I'm curious. What are those?
Oh, no.
Why are they a problem?
There are these weird distortions that can pop up in videos when you're dealing with high compression ratios.
Uh-huh.
They look like little blotches or speckles, you know?
Yeah.
Really distracting.
Ah, those little imperfections that ruin an otherwise perfect picture.
Huh.
What causes those? How did they fix it?
Well, they figured out that the problem was stemming from a technique called group normalization.
Normalization. That rings a bell. Isn't that kind of like adjusting the volume levels in a song to make sure everything blends together nicely?
Exactly. But in this case, the group normalization was actually creating some unintended consequences.
Oh, no.
It was like one of the instruments was slightly out of tune, and it was creating a weird, off-putting sound.
So what did they do? Did they just get rid of group normalization altogether?
Not quite. They found a clever way to tweak it by getting rid of something called the mean subtraction step.
Okay.
It's a subtle adjustment, but it was enough to get rid of those annoying spot artifacts without messing up the overall benefits of normalization.
So they basically just fine-tuned that out-of-tune instrument instead of getting rid of it completely.
Precisely. And this attention to detail is what makes this paper so impressive. It's not just about big ideas, but about carefully solving the little problems that can make or break a technology.
I'm loving this deep dive into the nitty-gritty details. But before we go on to our novel notions segment, where we let our imaginations run wild, I think it's important to talk about how ProMag actually does this progressive growing.
Yeah, absolutely. That's where the real genius of this paper shines through. The researchers didn't just stumble upon this method, they really put it to the test.
Oh, how so?
They tried out a more straightforward way of progressively training the model, like just adding more layers as they went along, but without that clever information flow from the lower compression models.
So it's like building that house without a proper blueprint, right? Just adding rooms randomly and hoping for the best.
Exactly, and, well, you can imagine how that turned out. It did lead to some improvements compared to just training a high compression model right from the start, but it was nowhere near as good as ProMag. That guided information flow, that hierarchical structure, it turned out to be super important.
So it's not just about adding more stuff, it's about adding the right stuff in the right way.
You got it. And they didn't stop there. They also tested ProMag against another idea using a lower compression model on a smaller version of the video, and then using a separate algorithm to fill in the gaps, like taking that flip book we talked about and trying to smooth out the animation by drawing in the missing frames yourself.
That sounds like it could work. You're basically outsourcing the compression to a different algorithm, right?
Yeah.
What's wrong with that approach?
Well, the problem is that those algorithms, while good at filling in some blanks, tend to struggle when there's a lot of fast movement or complex scenes. They end up blurring things or creating weird artifacts.
So it's like trying to fix a blurry photo by just smearing the pixels around. You might make it look smoother, but you lose a lot of detail.
You're exactly right. And when they compared ProMag to this subsampling and interpolation combo, the results were very clear. ProMag was consistently better, especially in those tricky high motion scenes where it could preserve details that the other method just couldn't.
It's almost like ProMag has learned its own way of filling in those missing frames, one that's specifically designed for video.
Exactly. And that's really what sets it apart. It's not just about reducing the number of frames. It's about truly understanding the dynamics of the video and representing them accurately.
Well, I am super impressed with the ingenuity on display in this paper. But before we move on to our novel notions segment and really let loose, I think it's worth acknowledging that no research is perfect, right? What are some of the limitations that the authors identified? Where do you see opportunities for future research?
Absolutely. Every breakthrough opens up new questions. And while ProMag has achieved some amazing results, there's always room for improvement. They pointed out that even though their high compression models are way better than anything that's come before, they can still create some weird artifacts when the motion is really extreme.
So even though ProMag is a huge step forward, there's still a gap between what it can do and the ideal of perfectly reconstructing a video, especially in those super challenging cases.
Right. And another area that could use more research is how the text-to-video model is trained. The authors noticed that using a more compressed representation of the video can sometimes lead to slightly slower training times.
So it takes a bit longer for the AI to learn and get really good when it's working with that super compressed data.
Yes.
Okay.
And that suggests that there might be a bit of a trade-off between compression efficiency and training speed. Like, you could have a faster car that takes a bit longer to warm up, or a slower car that's ready to go instantly.
Interesting. So finding ways to improve that trade-off could be a promising area for future research.
Exactly. Maybe new training techniques or new compression schemes could make a difference there.
I'd love to see where this research goes. But speaking of pushing the boundaries, are you ready for some novel notions inspired by ProMag?
Always. Let's get those creative juices flowing.
All right, let's do it.
Welcome back to the deep dive. When we left off, we were thinking about using ProMag to compress brain activity.
Yeah, that was a wild one, right?
Huh.
But it just goes to show that ProMag could have some seriously big implications.
No doubt. ProMag isn't just about making videos smaller, it's about giving AI the power to create completely new ones, potentially even whole new worlds.
And that brings us to personalized entertainment.
Oh, yeah.
Imagine movies or video games that can change in real time based on what you like, how you're feeling,
Yeah,
even your emotions.
that's right. Imagine a movie where the story changes depending on the choices you make, or a game where the environment reacts to your emotions.
That's like having a personal director creating a unique experience just for you.
And ProMag could make that possible, you know? Because it can compress video data so efficiently, AI models could potentially create and change video content on the fly.
So instead of just watching what's already been made, we could actually shape the stories we experience.
Exactly. And this kind of personalization could change education, too.
Oh yeah, personalized learning. That's been a dream for a long time, but it's never really worked out, has it?
Not really, but ProMag could change that. Imagine educational videos that change their pace and difficulty based on how well you're understanding things, or virtual tutors that can explain stuff in a way that makes sense to you.
Wow. We could finally move away from that one-size-fits-all approach to education.
Yeah, and it's not just about what you're thinking, it's about how you're feeling, too. What if an educational program could sense if you're getting frustrated and change things up to help you out?
Like, if you're struggling, the program could slow down, or maybe even tell a joke to lighten the mood.
Exactly. It would be like having a teacher who really understands you and knows how to help you learn best.
This is pretty amazing stuff. But I have to ask, are there any downsides to all this personalization? Could it create echo chambers where we only see things that reinforce our existing beliefs?
You're right to bring that up. That's something we need to be very careful about. Like any powerful technology, it can be misused. But I think the potential benefits are worth it as long as we approach it responsibly.
I agree. It's about finding that sweet spot where we empower individuals without sacrificing our shared understanding of the world.
Exactly. And I think ProMag, with its ability to create more efficient and adaptable AI models, could help us find that balance.
This conversation has really got me thinking. But we're not done yet, are we? We still have novel notions to explore.
Of course. Always time for some blue sky thinking. What's on your mind?
Well, we talked about personalized video, but what if we went even further?
Oh.
What if we used ProMag to create virtual worlds that change based on what people do in them?
Whoa, hold on. You're talking about virtual worlds that are not just immersive, but also interactive and alive?
That's the idea. Imagine a world where you could build a city and the environment around it would change to support the growth. Or if you polluted a river, you'd actually see the ecosystem suffer. It would be like playing God in a virtual sandbox.
That sounds incredible for gaming and simulations, but could it be used for something more practical?
Definitely. Think about urban planning, environmental conservation, or even social policy. We could test out different scenarios in these virtual worlds and see what happens without any real-world consequences.
It would be like having a giant laboratory where we could experiment with different ideas and solutions.
Exactly. And ProMag, with its ability to create and manipulate such complex visuals, could be the key to making this happen.
This is mind-blowing stuff. Of course, it would be super challenging to build AI that can handle such complex interactions and predict what would happen over time.
And the worlds themselves would need to be incredibly detailed and realistic. It's a huge task, but not impossible.
You're right, it's a challenge worthy of the best minds out there. Who knows, maybe ProMag is just the first step towards making these virtual worlds a reality.
What a journey. We've talked about personalized entertainment, the future of education, and even dynamic virtual worlds.
ProMag is making us rethink what's possible with AI.
But we're not quite finished yet.
Yeah.
We've got one more part of this deep dive to go. Come back next time as we explore even more amazing possibilities in AI video generation.
Until then, keep those imaginations running wild.
Welcome back. We're wrapping up our deep dive into ProMag today. Still can't get over those AI-powered virtual worlds we were talking about last time, the ones that change based on what we do.
Yeah, that was a pretty wild thought, wasn't it? But
Right.
ProMag really shows us how AI can bridge the gap between the real world and the digital world.
Exactly. And it got me thinking, what if we could take that concept even further? Like, what if we used ProMag to make a visual search engine for real-world events?
A visual search engine.
Yeah, like imagine you could type in a description of something that happened, like, say, a car accident or a protest. And AI could search through all the video footage out there from security cameras, smartphones, drones, to find and put together a visual story of what actually went down.
Wow. That would be amazing for investigations, for historical research, even for things like criminal justice. Instead of relying on just people's memories or snippets of video, we could have AI build a complete picture of events as they unfolded.
Exactly. It would be like having a time machine that could rewind and replay real-world events. Of course, there's some big hurdles to overcome, right? We need to teach AI to understand not just what it's seeing, but also the context, the order of events, the connections between people and objects.
Right. And it would have to be used responsibly, of course. Imagine if someone used it to create fake videos that looked totally real.
Yeah, that's definitely something to think about. The ethical side of this is huge. But if we can figure that out, this tech could completely change how we understand the world around us.
It just shows that AI isn't just about making things easier or faster. It's about helping us make sense of this crazy, complex world we live in.
Well said. I think we've climbed to the top of Mount ProMag. We've talked about the technical breakthroughs, the amazing potential, and even some pretty out there ideas.
It's been quite the journey. I hope our listeners are feeling as inspired as I am.
I hope so too. So listeners, go check out the ProMag paper for yourselves. Get curious, let your imaginations run wild, and who knows, maybe you'll be the ones to take this research even further.
Yeah. And we always love hearing from you. Leave a comment, send us a message, keep this conversation going.
That brings us to the end of our deep dive into ProMag. Thanks for coming along with us on this amazing intellectual adventure.
Until next time, keep those minds curious and those imaginations sparked.
And remember, the future of AI is a story we're all writing together. Let's make it a good one.